Here we're given a trigonometric equation that has a quadratic form, or at least right now a quadratic term in it, and we've been asked to solve it on the interval from 0 to 2 pi. And so the first thing I need to do is to get this all in terms of one trigonometric function instead of having tangents and secants in it. So I see the equation 2 tangent t minus secant squared t equals 0. And just the secant squared part's giving me the impression that I might be able to use a Pythagorean identity. In fact, I know that tangent squared t plus 1 is equal to secant squared t. And that'll give me the ability just to make a swap here of secant for tangent squared plus 1 and get everything in this equation in terms of tangent. So let's just go on and do that. All right, and so now let's see what happens. I'm going to distribute things through and rewrite this in a pretty standard quadratic form. So I'd have a minus tangent squared t plus 2 tangent t minus 1 is equal to 0. Now, I'm a little better dealing with quadratics when the leading coefficient is a positive 1, so I'm going to multiply both sides of this equation by a minus 1, giving me a positive tangent squared minus 2 tangent t plus 1 is equal to 0. Looking at this quadratic form, what I realize is that it is actually a perfect square trinomial. It factors into tangent t minus 1 all squared. Well, setting the only bit with a variable in it equal to 0, you could also think about taking the square root of both sides, but I get the tangent of t minus 1 is equal to 0. Adding 1 to both sides, I have the tangent of t is equal to 1. And I'm only worried about that first full revolution, and tangent is equal to 1 at pi fourths, and then the period of tangent pi later at 5 pi fourths. And that's it for now.